So I'm Mr. Oladimeji. I would like to introduce myself. My name is Adejuma Ridwan Suleiman. So I'm a data scientist working with Business Data Laboratory. So Business Data Laboratory is a consulting firm in Abuja. And welcome to our R session. That is our data analysis with R. We're going to talk about R and how you can get started with data analysis using R. So I also like to know more about you, so your profession and why you are interested in this class.
Okay, good evening. I'm a core member. I'm serving in Lagos. I also schooled in Lagos. I studied electrical engineering. From my primary level, I've been interested in data science. So I've been coding in Python and R. But I've been really moved since then. I mean, since I think 2020.
Wow.
But I've been doing that all on myself. So, the path of data science can be so, especially when you don't have any mentor to guide you. So I've been going back and forth, but then I've been in the cycle. I've not relented. I've been doing it here and there and all of that. So I'm not new to R. I'm not new to Python, but I'm not in the intermediate level yet.
So this is like a refresher. It's going to be like a refresher, right? Okay, I said it's going to be like a refresher, right? Okay. Okay, are you hearing me clearly? Okay, so let me just get started. So to our agenda for today, I'm going to introduce our company and also introduce myself and talk about our today's takeaway, Q&A after the session, and also a thank you note. So our today's takeaway is why a career as a data analyst. So why choosing a career as a data analyst instead of other fields? So we also have other fields that are there. We have software engineering, we have virtual reality, we have UI UX. So why career as a data analyst? That's going to be our takeaway. And also why the R programming language, because we have other tools for data analysis. So why are we talking about R? Why are we using R? Then why learning from us? So I want to know why it's good, what's the benefits, what's in it for you to learn from us. And also we're going to be introducing our instructors at Business Data Laboratory. So now, why a career as a data analyst? So who is a data analyst? So a data analyst is someone that actually gets insights from data, and after getting this insight from data, use these insights to make decisions from this particular data. So the first thing that a data analyst actually does is that a data analyst sources and gathers data. So this, most of the time, this data that we're talking about, first of all, before even sourcing and gathering the data, one needs to know the problem statement. So what do I want to solve? Which problem do I actually want to solve? So what am I solving? What problem I want to solve? What do I want to achieve? So that is now when you now know, okay, this is the data I need, and this is where and where I can get this particular data. So I want to solve a particular problem. It might be a business problem. It might be a personal project. It might be a personal problem, something like that. But you have to source what and gather that data yourself for you to be able to solve that problem. So the first step is actually your problem statement. So you need to define your problem, which is what a data analyst actually does. The data analyst defines his or her problem, then what sources and gather the data regarding to that problem. So after sourcing and gathering this data, the data analyst will now clean and organize it, because most of the times this data comes in dirty format. So they don't come neat, they don't come tidy. So it is the work of the data analyst to actually clean and organize this data. So when the data analyst clean and organize this particular data, then the data analyst can now further continue to work. So the data analyst can now further towards make meaningful conclusions or insights from that particular data. The data analyst use the data to reach meaningful conclusions by getting insights from that particular data. So you have sourced and gathered the data, you have cleaned and organized it. What is left now is to just use your tool, the tool that you are interested in, to now make insights from this particular data and use it to reach meaningful conclusion. After that, then it is the work of the data analyst to now communicate the results to stakeholders or maybe the management. Or if it is actually a personal project, you now communicate the results to others through visuals and reports, so that people will be able to understand it. That, okay, this was the work you have done, this was what you are able to achieve, and this was what you are able to do with the data set which you have already sourced and gathered. So now a data analyst role actually just summarized in this particular steps we explain now. Problem statement, sourcing and gathering data, cleaning and organizing data, deriving insights from data and communicating this particular data. So it's one of the important skills for a data analyst, not just know how to analyze this data using a specific tool, but also how to what, to have a good communication skill to be able to what, pass this information, because most of the time this information might be technical and might not be easy for someone to understand. So it is the work of data analysts to be able to what, interpret it for laymen. So we're going to just put in that situation like laymen, which they'll be able to understand from the visual. Okay, anybody that sees the visual will know that, okay, this is what is happening in this particular data, and this is how this data is actually going to solve our problem, or this is what we can achieve from this particular data. So now, why a career now as a data analyst? So the first of all, now the salary spec, which is ranges around 168 to 481,000 naira. This is for someone that is actually in an entry role. For those experienced, actually it can be higher than this. Or for those within this outside the scope of Nigeria, it can actually be higher than this. But most of the time, from sites like Glassdoor, you see that the range in Nigeria ranges from 168 to 481,000 naira. And also, another advantage as a data analyst is the ability to work remote and hybrid, which is almost applicable to most tech jobs or tech careers. So you'll be able to work from the comfort of your home, or also work in an hybrid position. That is, you go once in a while to the site. So this is one of the benefits, one of the perks of being a data analyst. The work can be done remotely. So, and some of the times, even when you want to go into freelancing also, there's no even need to even know your clients. Your client is just interested in you solving his or her problem. By using the data, the client is actually going to give you, and you just give the client the insight. So freelance is also another way which one can have a career as a data analyst. So you're not under a particular paycheck. You just work for a client, either on an hourly basis or on a project basis. And of course, you can also start your own consulting firm, just like our consulting firm now, Business Data Laboratory. We help organizations to be able to solve their problems and derive insights from their problems. So this is also one of this is one of the benefits which one can get as a data analyst, and one of the importance of having a career as a data analyst. So now, why learn from Business Data Laboratory? So Business Data Laboratory is actually a consulting firm based in Abuja. So we help organizations solve problems from their data. So organizations give us their data to be able to derive business decisions from this particular data, and we in turn give them the insights we derive from this particular data. So we also use data science tools such as Python, R, to also help us to be able to solve problems for these particular organizations. And we also conduct training sessions, which is one of them that we're conducting now. We conduct free classes, we also conduct paid classes. So we'll conduct sessions, workshops, and seminars for those that are interested in learning the tools used in data science and also in data analysis. So our classes are in person. So this is our office in this is our training session in Abuja. We have classes which are in person for those who feel like they are interested in physical classes. We also have virtual classes which usually come in form of Zoom meetings. We have shared document management, and also have recorded classes. We also have email /chat messenger. We have weekly /weekend online classes. So for those whose schedule is not flexible to be able to fit in with the physical classes and are comfortable taking virtual classes, we have Zoom meetings arranged for them. We also have shared document management, and we also record our classes for those who missed the live classes. They can actually rewatch the live classes because we already recorded it, and also chat with our students to get feedback on their progress, and also track their progress using email and chat messenger. And for those who might not be available in the week during our week classes, we also have weekend online classes also for them. So our curriculum is actually skill-tailored curriculum, and we have dedicated and supportive instructors, so which I'm also one of them. And our schedule is flexible, so that is no matter how busy you are, we have schedule that is going to be tailored to support you. We also have virtual classes for those that might not be able to meet up physical classes, and we have portfolio-ready projects. So our curriculum is portfolio-based, so which means you have to conduct a project using real-life data sets. You work with real-life data sets, and these projects you conduct, you can be able to show any employer which you want to apply in an organization that these are what I'll be able to do with the skills I have and the skills I've already earned. So most of these data sets that you'll be working with are real life, and you'll be able to also collaborate with others, because in the real life, you have to collaborate with others. You cannot just do all. So a particular person can handle another part, let's say data cleaning, while you handle the the derivation of the insights from that particular data. So collaboration is also one thing we are trying to promote in our curriculum and also trying to encourage among students. So our instructors, first of all, one of our first instructor here is Bilkisu Wumi Olatunji. She has an MSc in Information Technology, and also she's a data scientist and R Shiny developer, and also a certified R Studio instructor. So, and she's also a certified Scrum Master, product owner, and also an Agile coach. So then we have Amayiraho Robinson. He's from Uganda. He's also a data scientist and also a statistician, and also an R Shiny developer and a certified R Studio instructor. And also this is Adeju Modiron Suleiman, also a statistician, a data scientist, and an R Shiny developer. I'm also a instructor on Udemy. And then also our last instructor is Farida Bukola Bello, who's also a statistician, a data scientist, and R Shiny developer, and also a certified Scrum Master. So now introduction to R now programming. So the tool we're going to be talking about, we have various tools for data analysis. We have a lot of them. Excel is one of the basic or the most popular, I'm going to put it, which everybody knows. But sometimes the work gets advanced and one needs what's more advanced tools to handle advanced problems. So this is where programming language now come into play, to be able to use programming language to analyze data because of their versatility and the ability to be able to handle complex problems. One of these programming languages is the R programming language, which is also used in data analysis. So now, what is R? So R is a programming language suited environment for statistical computing and graphics. So R is a programming language, but under the domain of statistical computing and graphics, which means it is like a programming language designed to solve statistical problem and also create graphical representations or visualizations. So we have other programming language with their domain field. So we can put a programming language like R as a language which is used for statistical computing, just like we have something like JavaScript, which it is used in web development. We also have something like C++, which is also, we know it is used in hardware or embedded systems. So when it comes to R, though one of the things with programming language is that even though a programming language can be used for a particular domain field or niche, it can also be because it's a programming language, it can be taken advantage of and also used in other areas. But we know that everybody knows R to be a statistical programming language. And it is used in field of data science for data analysis. We have visualization and also statistical modeling. So which means we can find R in data science. We can also find in data analysis. We can also use what is also popular in terms of data visualization, because R creates very good graphics and also statistical modeling for creating models. Why R? So why are we now choosing R? Why are we using R? So one of the main advantages of using the R program is because it is open source. So when you say a program language is open source, it means it is free to use and it is not licensed. So unlike a tool like Excel is actually paid, or a tool like SAS or a tool like SPSS. So these are tools which are actually paid, and it's not everybody that has the ability or capability to be able to pay for this particular software. So this is one of the advantages that R has. R, it is free for everyone to use. It's also free for everybody to contribute to R. So if you have a feature which you as a developer develop and you feel like people will benefit from this particular feature, you can add this feature to R and it will be welcomed by the community. So this is why it is open source. And also anytime someone add a feature to R, even you can also benefit from this particular feature. So it has a large community of users which are willing to help you anytime you come across an issue or you face a problem when developing or when analyzing your data. So if you face an issue with R, we have people that are ready to help you online and also offline. So it also offers a variety of packages for data manipulation, machine learning, and visualization. So you don't need to create something from the scratch or you reinvent the wheel. R has a lot of variety of packages which can help you to perform any task that you want to do. Almost most of the tasks you'll be performing R have packages for it or for ready-made functions for it. So no need of you starting from scratch to create something that will solve a particular problem for you. Be it in data manipulation, be it in machine learning, or even in visualization. A lot of tools are available for you. A lot of packages are available for you in R. And these are developed by both of the R users. Even you on your own, you can also develop a package which you think would be beneficial for the R community, and everybody is going to benefit from it. So that is one thing with the open source community. We create packages, or we create features in a particular programming language just to help ourselves and make life easier for us. So it is also widely used in academia and industry. R is also known to be used in academia. Under other programming languages, R has a very wide popularity in terms of in academia. It is also popular in industries. So it is a very valuable skill. So if you are someone in academia, it's with a knowledge of R, it's easy to switch to industry. And if you are someone in industry with knowledge of R, it's easy to also switch to academia. And it is flexible and allow users to create custom function and scripts. So this is something I created, I talked about in packages. So creating your own function and script so that others can be able to use it and to be able to perform other tasks. It is possible that a task which you want to do, you might not find a package to perform that particular task or function. So you can actually create yours and now share it for others to be able to use. So how do you now get started with R? So first of all, we have R and we have R Studio. So before you get started with using R, you need to install R first. So you need to install R. So you can see this is the R website as I'm looking on my screen. So if you are on Windows, you download R for Windows. If you are on Mac OS, you download R for Mac OS. If you are on Linux, you download, this is optional to download R for Linux. So this is the first thing you are going to be installing first. You install the R before you now install R Studio. So I'm going to first, I'm going to now give the difference between R and R Studio. So this is R Studio IDE. So an IDE means integrated development environment. So you can take, it's not as if you can't actually perform. So this is the R, you can see it. So you can download and install R. So this is the site, you can download and install it from here. So I don't know, do all of you have R installed on your PC?
No, not yet.
Okay. Maybe, okay.
I think we can use the online ID, which is the POSIT.
Yeah. Yes, it's true. Yeah, there's online ID. You guys can also use that. I don't know if others also have the link to that. You can just Google POSIT share online. Or Mr. Oladimeji, you can share it on the chat. I don't know if you can do that. Share the link for them.
Okay, I'll do that now.
Yeah, that will be very good. I really appreciate that. Okay. So now what is the difference between R and R Studio IDE? So the thing is that you can actually use the R itself, but we can, a simple analogy which I can just give between R and R Studio IDE is that we can take a R like a manual transmission system for those of you that drive cars. So you can take the R as something like that, while the R Studio IDE is like an automatic transmission system, which means that there are some things which is going to be very difficult for you to do in R, but it's going to be easier for you to do in R Studio. And the R Studio make it presentable for you and make it easy for you, makes your life easier when trying to develop or when trying to perform data analysis tasks. Even your visualizations, easier to save, easier to export, and so easier to import when using the R Studio IDE. So the R can actually work without the R Studio IDE, but the R Studio IDE can't work without R. So which means the R Studio IDE is dependent on R. So you need this tool to be installed on your system to be able to now use the R Studio IDE. So most of the time, you won't even be using the R, you will be using the R Studio IDE, because the R Studio IDE is actually based on the R. So if you want to analyze any data, you will just open the R Studio IDE, you will not be opening the R, because this R Studio IDE already have the R backing it up. So you're going to be able to now perform your analysis or perform any task which you now want to perform. So now, let me just open the R Studio IDE so that we're going to get to see it. So you can see now on my screen, this is the R Studio IDE. So yours, maybe if you already have it installed, yours might not look the same with mine, because if by default, this particular place that you're looking at, so we actually call these pins, so we call them pins. So here that you're looking at is our script pane. This side you are seeing is our console pane. Here also our files pane, and here we have our environment pane. So if under our environment pane, you can see other tabs too, also like history, connections, Git, and tutorial. I'll be explaining all this later on. Also have plots, packages, help, view, and presentation. So these are other tabs, which when you click on, you have other options. Like plots allow you to be able to view your plots. Packages allow you to be able to load packages. So when we go to packages, I'll explain packages, but this allows you to be able to use external packages here and load them. We also have the code which can use to load packages. So these are just the 4 pins. So by default, you're going to be seeing your console pane by this side. So this is because I customized mine. Why you're going to be seeing your environment pane by this particular place. So just like I just swapped it in mine. So by default, so all is the same thing. It's just based on your preference. What do you want? And here you can see all the files on your local machine. So all the files on your PC, you can access them from here without going outside R Studio IDE. So if you have files, you can actually access it from that place. Okay, Mr. Oladimeji, thank you for sharing the site. So I don't know if we're clear. So if you go up now, we are going to be seeing tabs. So these are tabs which, just like most softwares, they have tabs which you can access, allow you to be able to access operations in the particular tool. So you can see our file tab, anything relating to file manipulation, saving of file, creating a file, you can get that at the file tab. So these are the options which you see we are viewing. Then also, you can also see the edit. I'll also be able to edit your codes and anything you write. So you are going to be able to access that also in the edit, and also have the code. So anything relating to code also. So you are going, or running of code, any operation relating to your code or your scripts, you're able to access it through this particular code tab. Also have the view. That's to customize the view of this particular RStudio IDE. We have plots also. We have session, we have build, debug, profile, tools, and app. So most of the times, the majority of the time, what you are going to be using mostly will be the file, edits, code, view, plots. So it's only once in a while I'm going to be using these tools of session, build, debug, and profile, maybe in advanced tasks. We also have the tools. So this is where you can actually customize your RStudio IDE. So when you go to tools and go to global option, so this is where you can now customize your RStudio IDE fully. So where I actually swapped my pins was at pin layouts. So you can see pin layouts now. I can just click on here, you can see, and choose the particular pin I want to swap it with, so which is console. So you can see that console has already come here. So when I come here and click OK, so you can see that it has already changed. So my console is here, while my environment has already been swapped. So this is default. When you install R and RStudio, this is what you're going to be getting by default. So I'll go back to my tools now. So revert the change I just made, my pin layout. I'll just click on this console here and click environment history. So any option I click here is going to swap that position with that particular option. So now also how you can change your appearance, because your appearance is not going to come in like this by default. So most of the time it comes white. So this is the Cobalt theme. When you click on appearance, you're able to access the Cobalt theme. So you can see it. We have a lot of themes which you can use. So it depends on your preference, the type of theme you actually want to use. So anything you want to use, you also want to change the font size, you can change it here. The zoom, you can see we also have RStudio theme here. We have the font style, the font name. You can see it, which is Lucida Console. So these are things which you can actually play with. So I really advise you install the R and the RStudio. So maybe when I share the slides, you're able to access the link from the slides and be able to install the R and RStudio and also explore most of these particular settings. We also have other editings. We also have the general settings. So general settings are there. So there are a lot of settings which one can do under the global options. So appearance is going to actually customize the appearance of your IDE. So let me read this. Okay. Back to tools, global options, appearance, rights, opinions. Okay. Okay, so let's go back to our slide. So sorry. We have okay, sorry, any question?
No, it's fine, sorry.
Okay. So one thing also, one interesting thing that the slide they're actually looking at was actually created in using RStudio. So these are one of the things which one can do. So it's not just only about data analysis tasks, it's all about creating or publishing. Like this particular slide you are viewing now was created in R using a Quarto. You can also create books. You can also create articles. You can also create a static site also using R. So most of these are just packages developed by people just to ease processes. So instead of going to another programming language to do something, do all because most of the time you cannot go to PowerPoint and say you want to be putting code in PowerPoint with the output. So this is one of the benefits of using packages like this. So we have our file project and file structure in our RStudio IDE. So when you want to set up a project, we have what you call a project. So when you create a project in RStudio, you don't just create a folder or a file. So when you want to perform a task in RStudio, you have to create a project. You have to set up your project name. So when you set up your project name, you're going to have a file like this, which means I've already created a project. I will show it practically later on. So this is what is going to show that, yes, you have actually created a project. Then inside this particular project that you now have, we now have folders. So I'm going to be having your data folder. So this folder is where I'm going to be storing any data you want to work with. Then we have our scripts folder. So under our script folder now falls the script which you use for analysis. You can have analysis A, you can also have analysis B, and you can have custom functions which I've already created. You can actually store that inside a subfolder under the script folder. Also have the output folder. So your output now from your analysis, you can have plots, a folder of plots where you're going to be storing your plots, maybe a bar graph, a pie chart, or a line graph. Also have the data folder where you're going to be storing analysis of your data. That's the output, because it's possible when during analysis you derive a data from a data. So maybe a summarized data which you have from the main data. So you can actually store those outputs under the data folder. So this is basically a basic R project setup. So this is how you want to create a project in R. Then you are now, this is the setup which you are going to be using. So now let me okay, so starting up on our R, it's a new session. Okay, so now, so this is how it looks like now. Open it by default. So earlier on was actually,
we can't see your studio actually.
You can't see it?
We can't see your studio. We're seeing the slide, and that was the same thing that happened the other time when you were explaining coming on.
Sorry for that. Let me check. It seems it's from the sharing screen. Okay. I need to explain that. Okay, let me stop the share. Yeah, I'm sorry for that. I don't know. Okay, are you seeing it now?
Yes, we can see your studio now.
Okay, let me just go away. Let me go again, please. So please bear with me. Okay. Okay, so earlier I was explaining that when you want to load R, after installing your R and R Studio, normally by default, the R has a white theme. So you're going to be seeing like a white background. And also, these are the pins we have in R Studio. So we call this the script pane, this particular pin you're looking at. We call this the console pane, and we call this the file pane, and we call this the environment pane. We also have other tabs by the environment, which are the history, connections, Git, and tutorial. We also have plots, packages, help, viewer, and presentation. So most of the time, when you load something that is supposed to come out on the web or a web file, it usually comes out under presentation. Why the plots? You are going to be, anytime you build a plot or you create a plot, the result of the plot is going to fall under the plots tab. So now this, by default, your console tab is going to be at this side, and the environment tab is going to be at this particular place.
Tofika, you can go ahead.
Go ahead with what?
Teaching us now. You are the boss. Why are you laughing now? We can go ahead and teach us.
Oh yeah, take the floor till we resume. Abby will come back. You dropped the link now. Oh yeah, tell us how to navigate through it.
JC, can you please teach us, please? JC, please, can you continue?
Just take the floor.
Which slide? Anyways, that the link I dropped is just what you're going to see there is the same thing as the R Studio. I mean, it's the R developers that came up with the site. You know, just like we have Jupyter, you can use Google Colab.
And Google, okay.
So the same thing with R Studio and Posit. So they changed R Studio name to Posit. I think towards the end of was it last year? Yeah, I think it was last year or last 2 years. I think it's last 2 years. They've already changed R Studio to Posit.
Oh.
Yeah, so it's official. It's not like they are not two different things. They are the same thing. Posit and R Studio. It's just because of the online collaboratory tool that they came up with. That's why they are now calling it Posit. So it's like acronym, sure.
Okay. Yeah. Oh, they even have premium.
Have you signed up already?
Yes, I'm trying to.
Yeah, it's very easy actually. So when you open it, you're going to see R Studio. But I think one of the advantages is that you can use it. You can even use it on phone because I'm viewing it on phone like this, so you can start coding on phone. You cannot install R Studio on your phone, but you can use the online stuff on your phone, just like Google Colab.
Sorry, please, everyone. Network provider issue. Nigeria factor. Nigeria factor. Sorry, please. Okay, let me see. Okay, sorry. This is where I was talking about customizing your team. So I don't know. Everybody's clear with this particular layout. So we have the pin layout. So this is where you can actually swap it. So normally by default, when you click on a particular pin here, so any option you're going to choose is going to swap with that particular option. So I'm going to be clicking console. So by the time I click on console now, you can see that I already swapped it to console. When I put on OK, you can see that I've already changed position. So this is by default, this is what you're going to be having when you install your R Studio. So I actually swapped mine. So it's just based on your preference. You can even bring your script editor. You can bring your script editor to this particular place here. So it's based on what you want. So there are other things you can also do. There are other settings which you can also do. Some of them are actually advanced settings and some of them are basic settings. So this is how you can actually use this, the global options. So I'm just going to be setting this console back to, okay. So earlier on, I was talking about setting up an R project. So this is a new R Studio window I opened. So I'm going to be showing you now how to create an R project and also how to create the folders I just mentioned earlier on. So when you click on File, so this is the File tab. It allows you to perform file manipulations. So when you click on File now, you're going to be seeing the option New Project. So by clicking on New Project now, so we're going to have a window open up for you. So do you want to create a new directory that is like a new folder or an existing directory? You already have a folder existing already. So you're going to create the project inside that particular folder or version control system. So we're going to be choosing new directory because we don't have any new folder. So I'm going to be putting on new directory. So when you go on that new directory, so there are a lot of projects which you can create. We have a new project, just a new project. This is the default. We also have an R package, a Shiny application, Quarto project, Quarto website. So a lot of options on there. So a lot of options. So the reason why we have most of these options is because most of them create projects based on what that particular use case. So they create projects with like a default file, default setup. So they have their default folder setups. That is why you can see them as various options. So we're going to be using new projects. So from new projects, we're going to be giving our directory a name. So let's just call it my first project. So I'm going to be calling it my first project, and I'm going to be putting it on in my documents. Or you could just change it to desktop. Open, then create projects. So one thing you should notice that when you create a project, you're going to be seen by the upper, that's the upper left corner. You're going to be seeing your project name. If you are not on a project, you're just going to see only RStudio, like earlier on. But when you're on a project, you're going to be seeing your project name. And under the files pane, you're going to be seeing what? Your project folder. So let me go to my file explorer now and show you this particular folder. So under my file explorer now, you can see my first project. So you can see my first project now. Just as it's showing on in RStudio. So you can see it is what's empty. So this is where you can now start creating your folders now based on what we have here. So you can start creating your folders now based on what we are having in this place. So first of all, now we're going to be creating our data folder. So if we want to create a data folder now, you're going to see an option of folder here. So you click on this particular folder. So you click on that particular folder icon, you click on the folder icon, and you put your folder name. So I'm going to be calling my folder data. So then, okay. So you can see this is my data folder. So I'm also going to be creating my scripts folder. The same thing, also scripts folder, then okay. So under my script folder, I also have a folder called for functions. So I'm going to click on scripts now. So when I click on scripts, you can see that our scripts are open. So this is the file paths for each particular folder. You can see we have the name of the PC, we have desktop, we have my first project, and we have scripts. So under scripts now, I'm going to be creating functions. So I'm going to be creating functions. Then okay. So I can now go back to what's my first project. So you can see all my folders. So I think we have one more last one, which is output. And under output, we have outputs. So we have outputs, and under output, we have plots. And we also have, I think the other one is data. So please, am I fast?
My hand is actually up.
Okay, okay.
Yeah, so I just want to ask a quick question. Okay. So what's the difference between all of these projects and the Shiny app? Because I've been hearing Shiny app. So
okay, Shiny app is actually a web application. So this is like an interactive web app for your data, for your analysis. So if you have an analysis, so instead of just creating just a basic report with a code and the plots. So you want your user to interact with that analysis. So to be able to find other insights, not just what you actually coded. So this is when you now create a Shiny app. So it's an interactive data visualization, which you do. So it's just like bringing all your reports into just one particular app, which the user can access online. So the user can be able to interact with it and also find other insights. So I've already designed the apps in such a way that anybody that interacts with the app is able to explore other insights from the data. But if you just perform an analysis, it's just going to be the code you just run on that particular analysis. So even if you say you want to be able to perform a lot of analysis on that particular data, you'll be having a lot of files. But with a Shiny app, anytime the user interacts with something, just a basic example now, with the Shiny app now, a user can be able to see the population of a particular country and also the population of just a state alone, just with the Shiny app. But imagine you now running a script or writing a script, analyzing for the whole country and analyzing for each state in Nigeria. So this is one of the advantages of what the Shiny app does. So any user that now wants to use that particular app will be able to analyze, interact with it and say, okay, this is what I'm interested in. This is what I want to see. This is what I want to do. So that's one of the difference between the Shiny app and just running a normal app script. I don't know if that's clear.
Okay, so can you also, is it only R language that you'll be writing with it, or you can also incorporate like HTML, CSS, and all of that?
Yeah, that's why, in fact, Shiny was even created, just to avoid people, because most people don't have knowledge of HTML and CSS. So with Shiny app, you just need only R. But yes, just only R. But behind, that is inside the package itself, there's bundle of HTML and CSS codes there. But because most people don't have the knowledge of HTML and CSS, that is why they just created the Shiny app. So we just have some functions just simple functions, you'll be able to create a working app within just few minutes. Just some simple functions have already created a working app. So they just want to make the life of people that are R programmers easier, because a lot of people don't have the time to go back and be learning HTML and CSS, but you can even customize the app with HTML and CSS. That's if you have the knowledge. You can go further ahead and customize your app based on what you want. So anybody that view the app is even an added advantage when you have it. You customize the user interface of the app and also how the elements are looking like. But because most people don't have the knowledge of HTML and CSS, so they just design it with R functions. You use your R functions. Even most of the designing of the user interface is just with R functions. So in case you don't have the knowledge of HTML and CSS, you can still use China. You can also create a very beautiful working web app. So
okay, are we going to get there? Are we going to get to developing Shiny app?
Actually, Shiny app is not actually covered in this our free class. So it's actually covered in our paid class, which is coming up March. So okay. It's not really covered in this particular class. Yeah. Okay, so now you can see I've already created our project structure. This is how our project structure look like. We have data. You can see our project here. So this is the main thing that makes it a project. So without this particular file now, we know be having a project. You can also see the size and the date which it was last modified. So this is how you can now create a working project structure in R. They can now use it to perform anything you want to perform, and you store the files in any place you want to now store the particular files. So let's go back to our slide. So now, in terms of getting help in R Studio, we have the R Studio help. So most of the times you get stuck. So you get stuck or you need help in performance analysis, we have the R Studio help. So we have the R Studio help, and we also have R Studio community. We have the R Studio community. We also have search engines, and we have such as Google, and we also have Stack Overflow. So these are places where you can get help anytime you are facing an issue. Most of the time, this is what you're going to be using most, the Stack Overflow. So you're going to be getting solutions to most of the issues or the bugs or the errors you'll be facing, because it's a normal thing when you're using programming language, you face errors. So it's these errors that you just take online to search help for this particular error. So there's another thing searching for the error, for the help of the error. There's also another thing implementing that particular help you have into the problem which you want to actually solve. So now, as you can see now, currently now, this is R. You can see this is the name of the particular project R. So this is where this particular slide is stored. So this is the Quarto file which we have to use to render that particular slide. So now we have what we call the R script. So this is the script editor. So the difference between the script editor and the console is that in the scripts, you can actually run your code in the console, but the problem is that you cannot save that particular code and can only be run line by line. So this is where the script editor now comes. You can actually, if you have 5 lines of code, you type it in the script editor, and you want to run them all together, you just run the script. But under the console, you can only run it line by line. So you just take the console as a rough. So I'm to type 2 plus 2 now. You can see I'm going to be having 4. But if I type 2 plus 2 here, you can see I'm also going to be having the same answer. So they both of them work the same thing. They both work the same way. So either use the console, most of the time use the console to just test a particular code. So you want to see how a particular line of code works, or you'll be returning an error. You just come to the console and you type it. Why, when you know what you know that okay, this is working for you, they can now bring it to the script editor. So it's actually the script editor where you can now save it. So when you on your keyboard, when you type in Control S, so you're going to be saving it. So you can see you can now save your particular script. So we have various file types in R. This particular one is called a R file, while this one is called a markdown file. So a markdown file of different types. This is a Quarto markdown file. We also have the pure markdown file. We also have the R markdown file. So previously the R markdown used to be the most popular, but with the advent of Quarto now, which is .qmd, R markdown file is .rmd, while the regular markdown file is .md. So these are both markdown files. If you come to your file and new file, you see the file types which you can create in R. You can see R scripts, which most of the time is what you'll be creating. You can see Quarto documents, Quarto presentation, R notebook, R markdown, Shiny web app, Lumber API, C file, C++ file, header file. You can see the markdown file we're talking about. You can see HTML file, Anybody wants to customize his or our web app CSS file, we have JavaScript file, DT scripts. So we have a lot of files here.
Sorry, please. The Markdown file and the R Markdown, are they the same thing? And also, what's the difference between all of those ones and the Cohort document?
Yeah, the difference between the R Markdown and the Markdown file. The Markdown file now, you cannot render R code in the Markdown file. So you're not going to be getting outputs in the Markdown file. But when you use an R Markdown, anytime you run a code or you render that particular Markdown file, you'll be getting what your outputs. So the Markdown file is usually what is common to most programming languages. When you go to other programming languages, you can actually use the Markdown file. So in fact, some other programming languages you can actually render their output with the Markdown file. So that's why we now have what the RMD. So anytime you just want a particular code to just show without you being interested in the output, you can use a Markdown file. But if you now want your code or your outputs to be showing, you can now use an RMD file. Why a QMD file is just like a modified RMD file. So, but this one is just based on what Quarto and not based on what R. So with the QMD file, you can actually create a QMD file in another programming. Let's say, for example, you have another program like Python, you can create a QMD file. While RMD is only restricted to what R. That's why it's called R Markdown file. It's restricted to what R. So there's not much difference between what QMD and RMD. Actually, I can actually render this particular slide in RMD. I will still get the same output. So there's not much difference. You can actually use what RMD to also create slides. But where the difference is now is between the MD, that's the Markdown file, and the RMD, and also the QMD. So the Markdown file doesn't actually render outputs for you.
Okay, so does it mean that in the Quarto documents, you can combine R and another language?
Yes, you can have like Python now there and just be able to render the outputs of Python language. Yeah. HTML actually is not basically, HTML doesn't actually has any output. It only renders. So like anything you just type in, you get it in your web. So it's not actually like you have the output or a code you're actually running. So, but most of the time, the support of R Studio is just based on Python. Since we know that yes, R is meant for data science or something like that. So it's just based on Python. So you can actually create a Python file here, which you see it here. So, but creating a Python file also needs some external libraries to be installed or packages. So you need to install those packages there before you can now be able to create a Python file. Okay, so these are I don't know, is everybody clear with the file types I just explained now? And also the R script. This is what you'll be using most of the time. This particular R scripts is where you're going to be running your codes most of the times. Most of the times where you're going to be running your codes. So this is how it looks like. Let me show you a particular code under this QMD, how it looks like. Let me see. I think it should be down. Okay. So you can see it now, how it looks like. You can see how it looks like. So this is how a code. So without this now, without having this, I cannot be able to write a script and run it because we are talking about a QMD file. So this is what I'm going to be using to explain. I'll be using the console to type in some of the codes which I will be using. So I'm going to be using this to now explain this particular code I'll be typing in because you can actually use both of them. It's just that you can't save any code you write on that console. So what we'll be talking first now about is variables. So R variables. So these are like the basic fundamentals of programming. So every programming language have the way you create variables. And what are variables? They're actually containers for storing values. So instead of just using a value raw like that, or most of the time, say as a data analyst, if you want to import data, you cannot just be using your data raw. So you need to actually store that data in a variable, just like storing something in a container, so that I can be able to use it later on and to be able to perform any operation which you want to perform. So creating a variable in R is very simple. We have two ways. You can either use the assignment operator now. So let's say I want to store 4, the value 4 now inside the variable X. I can just use X and the assignment operator, then 5. So this is the less than sign and the minus sign. So the shortcut for this is Alt minus. So Alt minus is the shortcut for this. So this is the first assignment operator, which you can use to assign values. When I run this now, you can see I have what X equals to 5. When you check your environment, you're going to be seeing what values X5. This environment allows you to know that, yes, these are what you are working with in this particular script. If you don't see any value or any variable in this place, then even if you have to call that particular variable, you're going to get an error. So let me say I want to call Y now. You can see error, object Y not found, because I haven't created a variable called Y. So for me to be able to use Y now, I need to create a variable called Y. So I'll be using the equals to sign also to create a variable Y. So I'm going to be saying Y equals to 6. It's also another way of assigning a value to a variable. You can now see I now have Y is equals to 6. When I call Y by typing Y, You can see I have the value of what? 6. So now this environment window allows you to see anything you're working with, whether it is a function which you created, or a variable you created, or a data you just imported. If you don't see it in this place, then if you call that particular name, you're going to be getting an error. But once you're able to see all your values here, you're going to be able to see the values and also the variables here. Then when you now call it, you're not going to be having any issues. So any variable you create, this is where you're going to be seeing the results under your environment pin. So you can either use there's this assignment operator. This is the less than and the minus sign or the equal. So most of the time it's advisable to get used to this particular one. This is because of some advanced issue, but it's usually advisable to. So because this is what is anytime you check other people's code online, this is what you see as their own assignment operator. So just like how will I put it now? Just like making your code also uniform with others or other users too also. So you use the less than and the minus sign to assign a value to your variable. So you can see now currently now this variable now country, a variable country now. So if I click on this, if I actually want to run it, in the console, you want to run it, you just click on enter. Like now, y is equal to 6. Just type enter on your keyboard and it will run. But when you come to your script, like this place now, I want to create, I want to say, okay, C is equals to 4. So enter is not going to work. Enter will take me to a new line. So this is where I'm now going to use control enter. So when you use control enter, you now see your results in the console also. So use control enter, or you can just click on run also. You can click on run or use control enter. So this is what you can use on the script. But when you're on the control, you use the enter command. So currently now, this is like a script inside the QMD file. So that is why you're seeing it is shaded. So anytime you have something like this, it takes it as a script. So you can see it. So anything I run here is going to be a script. So I can now run country Nigeria. You can see I have the variable country with the value Nigeria. And I can also run age 62. You can see I have the value age. I also have the variable age and I have the value 62. So now I just created 2 types of variables. So this one is like the text and this is a number variable. So most of the times when you want to create a text, you have what is surrounded with double quotes. You cannot be having something like this, states. You now say Lagos. So this is wrong. When you run this, it tells you because ad is going to be looking for an object called Lagos. So that is why you also even need to take note of the syntax highlighting. When you are going to know that yes, you're having issues, when you're assigning, we are creating a variable and it's having color white, and your value is also having the color white, because color white is assigned to variables. But you can see a value most of the time. If it is text, they have the green color. If it is number, they have this magenta color. So now for me to be able to now run or create this particular variable without having any error, I need to highlight it and give it quotation marks. So when I now run it now, you can now see, okay, I have already detected it as a text value and created a variable called state. So syntax highlighting is very, very important when you're creating variables. You need to make sure that when you are typing a variable and you see your syntax highlighting is not matching with what you regularly see, then you are having an issue. So we have various ways of assessing a variable. Like now, the country we created earlier, I can say country and just type it, or I can just say print country. You can see these are both 2 ways of accessing the content of a variable. It's just based on what you want. Do you want to just call the variable name, or you want to use the print function? So we actually call these functions. So functions allows you to perform operations in R, and R is like built on top of functions. You're going to be using functions a lot in R. So most of the times you give the variables inside a function so that you get results from that particular functions. So just like now here, we have print country. We also have print of age. So what if now you want to assign multiple variables in R? So currently now you can see a particular line I have here, states, capital, and Kano. So what this does now is that, okay, I want to assign, I want to create a variable of states, which is Kano, and also capital, which is Kano. So instead of creating this 2 times, that's instead of just saying states, just saying states, Kano, and capital, Kano. So this is like, I just, now they're both having the same value, but they are different variables. So actually repeating this, why don't I just create a multiple assignment? So what in a multiple assignment, what happens is that what? First of all, you create a variable of what? Capital Kanu, as you are seeing it now, which means what? Capital is having the value of Kanu. Then the value of under capital is now going to be assigned to what? State. So you can see it now. So the value is going to, state is going to take the value that is what? Under capital. But mind you, we have to what? Capital has to be a valid variable name. You cannot have something like state now. Then you're now able to assign it to, let's just say LGA now. So you can see what object of LGA not found. But if LGA is already assigned to something already, that is a value like Kanu, when you run this, you're not going to be what having any error. And you're going to be seeing the results of all the variables we already created beneath here. So we have the C command, which we also call the combine function. So the process where what if you want to assign multiple values. Now we have been assigning what single values now to a particular variable. What if I want to assign multiple values now? I have a value now. I have a variable which I want to collect now. I'll call it states. So I cannot just say Kanu and now say comma. Then I'll say Lagos. So when I run this, I'm going to be having an error. So this is where the combine function comes. So I'm just going to now type states. Now use the combine function. So combine function allows you to be able to create multiple, assign multiple values to a single variable. I can now say Kanu. I can now put my comma and say Lagos. Now run this, you can now see I have a variable now of what? 2 elements, Kanu and Lagos. So this variable state now has what? 2 elements, Kanu and Lagos. So this is how you can now use the combine function. You want to assign multiple values to a single variable. So we have what we have. We have variable naming. So you don't just name your variables anyhow. We have some rules which one needs to follow when naming a particular variable. So first of all is that your variable name should be meaningful and descriptive of the value assigned to it. So you have to make sure what when you are creating a variable which is meaningful and descriptive. You cannot be naming. You cannot be importing your data. For example, now you are dealing about sales data. You want to analyze sales data. While importing that data, you now created a variable of that data. You call it Q. So this is not a meaningful description of your data, and anybody that's trying to read your analysis is going to find it confusing. So you have to make sure your variable name describing that particular value you are creating. If like I can see what I've been doing now, the value Kanu is created is using the variable name state. If you're having a sales data, you call it sales. In fact, it's even more discrete when you give also what is the sales about. Is it about bicycle sales? You call the variable bicycle sales. So you make sure you ensure that your variable name is describing your data. And also variables start with characters or a combination. We have variables have to start with characters or a combination of characters, underscores, digits, and periods. So for example, now let's have the look at these variables now. So you can see some variables in this particular place now. So look at this particular first variable now. First country is equal to Nigeria. You can see that all of the characters in the variable name is lowercase. So this is a variable, this is a valid variable name. So when you run this now, it's going to run without an error. Why this particular second one now is having an underscore. So you can see it is having an underscore. And also another thing, important thing to note, you can see that all the variable name is also in white color, which means this is a valid variable name. So we have now a combination of special character, which is underscore. Then we also have what lowercase characters. So when I also run this now, you can see that it is a valid variable name. This one also, we're having uppercase character with combination of lowercase. This is also a valid variable name. And here we also have uppercase characters also. It is also a valid variable name. Here now also we have a combination of characters and numbers, which is an alphanumeric. So here is also a valid variable name. But what if now we have a number here? You can now see that what all the variable name is not what white. So which means what this is not valid. So a variable name cannot start with a number. So this is an important thing to take note. A variable name cannot start with a number. In fact, RCF is even going to tell you that you can't create a variable from here. So before even running it, it's going to hint you that you're going likely to have an error. So you can actually have a number in between the characters or at the end of the characters. But starting a variable name with character is something that wouldn't work out. So here now, having the number at the extreme end is also a valid variable name. Having a period too also in between your characters is also a valid variable name. And also starting with a period is also a valid variable name. So these are what valid variable names. So in summary now, we can just say your variable name should not start with digits or underscores. And also, your variable name cannot start with a period followed by a digit. So let's have, like this now, we have a valid variable name with a period. So what if we have a digit here? You can see it now also. Even the syntax highlighting is not matching. So which means this is not a valid variable name. So now let's look at variables name which are not actually valid. So let me remove the comments. I'll explain comments now later on. So I think nobody needs to tell us that these particular variables are not variable names. From these squiggly lines, we can see that they are not valid variable names. This one is starting with a number. This one is also having a number at the extreme end, but with an hyphen. So we cannot have a hyphen in our variable names. Why this one is having a space, which is, we're not supposed to having this also as a variable name. And also this is, you can see this also is starting with an underscore. And also have this carrying a special character of @ so we cannot be having @ too also in a variable name. I also have keywords, special keywords in R, like false, we have true. You cannot create a variable name with true. So from the syntax highlighting, say, it tells you that this is not something you can use to create a variable name. We have we have I think 4. We have something like 4. So you can see it now, something like 4. So from syntax highlighting, this is not a valid variable name. So these are keywords. We have a lot of keywords. So one need to take note of these keywords and know that, okay, I cannot create a variable name using these particular keywords. So if you actually want to create true, you can just create something like this. So you can have a variable name like this. You can see it's even showing white. So in summary now, we know that a variable name cannot start with a number. We cannot also have some special characters in between our variable names, such as the hyphen and also the @. And also we cannot use keywords also when creating a variable name. So we have what we call comments. So you use comments when you don't want R to run a particular line of code. So now these are two codes now. You can see 2 + 2. So this is something that when I run Control Enter is going to run. But what if I have something like this now, #2 + 2? When I run this, you can see that, okay, let me just remove this. Okay, let me just bring this something here, 2 + 2. So you can see it now. We're not going to be having any result. Even if you create a variable now and the pound symbol is following it, you're going to take it as an empty line. So the pound symbol allows you to write comments on your code. Why we write comments as code is that you want anybody reading that is going through your analysis to be able to understand what happens to the code. So comment is just a short description. If you created a function that is going to perform a particular task, let's say you created a function that calculates histogram. So I'm just going to write a comment like, okay, function to calculate histogram. So this is what comment is going to be. So you should not confuse comment with what you actually have, something like your report. Report explains your analysis, why comment is going to be explaining your code. So anybody want to replicate your analysis will know that, okay, this is what this function actually does. And also you can even give more comments on how to customize these particular functions. So these are things that you are going to be seeing online when you go through other people's code. And it also makes code to be easy to understand, also to read. And also if you have a particular analysis which you don't want it to run, but you want it to be there because of maybe future reference, or you have something you want to go back to, you can assign the pound symbol all through the code. So as was anytime you run the particular scripts, that particular line of code is not going to be run. So once you also have to know that unlike other programming language where we have multi-line commenting, in R we only have single line commenting, so we don't have multi-line commenting. So if I want to add another line now, I still need to start with the the pound symbol. So if you also want to add another line, you start with the pound symbol. So this is how you can just create comments in multi-lines. So today we're going to be stopping in this particular place. So tomorrow we're going to be looking at operations which you can perform in R, and also get to look at the data types and data structures which you also have in R programming language. So this data type and structure allows us to be able to understand the type of value, the type in which a value is coming, and also how to store that particular value, and also how to handle or manipulate that particular value. So we have various data types. We just looked at 2 of them, which is numeric, and we just look at numeric, and we looked at text. So these are like two of the major common data types in R. numeric data types and also have text or string data types. So also have other data types in which data comes, like a data set now which you'll be working from in Excel has its own formatting, which is also going to be coming into R. So I don't know if there's any question.
Yeah, I just have one question. So if you want to present a report, like a report of an analysis, so you're saying it's better to use a Cohort document, right, rather than RMD, rather than R Markdown?
No, you can use any of them, just based on your choice. But QMD is what is just like, let me just put it like it. That's what is in vogue. Let me just put it like that. So you can use any of them. Let me just show you an example of an RMD now. You can see the various ways with which you can render an RMD file: HTML, PDF, or Word. So I'm going to be using HTML, okay. And when you type on HTML, so this is a default, the default file. So I'm going to be rendering this. So if I'm going, when you click on Neat renders it for you. Okay, I haven't saved it. Let me just give it. Let's call it P and so can you see how it looks like?
Like a Jupyter file.
Exactly, you understand. So this is how it looks like a Jupyter file. So you have your code here, you have your output here. You can hide the output if you want to hide it. You can also hide the code and show the output. So it allows you to customize it based on what you want. It looks exactly like a Jupyter notebook. So with your name here, your title, your name is there, the title of the document, and also the date which the document was last modified. The same thing to also happens with the QMD also. The QMD2 is also similar. I think let me create a QMD file and see. New QMD quarter documents. Let's create. So the QMD actually, it has like two interfaces. This is the source where you can actually type the code to customize it. You can see it's also somewhat different from the RMD in terms of that one is showing neat, this one is showing render. They're almost just the same thing. In fact, if you even have knowledge of how to manipulate the RMD, it's also the same thing applies with the QMD. It's just that the way the QMD actually renders the particular file. So now I want to render this now. Let me save it now. So let me just call it D and render this. So you can see the QMD also. So they're almost similar. So no difference with it. There's just the appearance, or let's just say the font style that was used in it. So there's not much difference.
Okay, thank you so much.
Most of the time when conducting analysis, this is what you're going to be using. So when you're on the RMD actually, like now, let me just clear this. Use the Alt minus. I think okay, Control Alt I, sorry. Control Alt I is where I'm going to put in your scripts. Anything you run here now, right? Put 2+2 here now. This is R is going to take it just like a normal text. So all your code you have to fall within this particular place. So any code will be going to be running should fall within this particular space. If your code is not here, then I will not take it as a code. Just take it as a normal text. So here you can just write, okay, and just describe your files here now and say, this is analysis of this. This is what I got from this. Why your code is not going to go here. So your output of the code will now fall below here. So if you want it to be hidden, you hide it. If you want it to be shown, you show it. So the same thing also you do here is what you do with QMD also.
So you're saying the report should be normal text, but we can.
You're just going to write just a normal text, just like you write in maybe a Jupyter notebook or something like that. Just write a normal text, just like, okay, this is a report, this is what your analysis, this is what you found out from your analysis, but your code is going to be within this particular place. Unlike the R scripts.
The pound sign to explain the code inside.
Yes, you can also use the pound sign inside this particular place. You can use it. You can use the pound sign, so you can see it. Also use the pound sign. So you can see it. So it's just like you're having a code inside a notebook. Anything outside it is just ordinary text. It's just ordinary text. So is there any other questions again?
No.
Okay. Sorry. Where's mine? Okay. Okay, Mrs. Taufikat. So is the class clear?
Yes, at least it is a bit.
The recording will be available on our YouTube channel. So I think I'll share the
Alright.
YouTube channel now. Then when we, maybe by tomorrow morning, God's willing, then you will be able to find the recording. So we have a morning and evening session. You can watch any of them, you can watch both. So just based on, just to clarify your understanding more, it's just the same, it's still the same thing. So
All right, thank you.
you are welcome. Thank you very much. So,
Bye.
okay. So let me share the link to the YouTube channel, or you can just search Business Data Laboratory in YouTube to actually have access to the content and also our previous classes also.
Okay.
Just Business Data Laboratory there. Okay. So Mr. Ladimechi, thank you for joining the class. Mr. Fikas, thank you also for being in the class. Really appreciate your presence.
Thank you so much.
Thank you.
So I think I'm going to draw the curtain here today.
Thanks.
See you tomorrow.